Let's take a look at a pretty basic example here. I want to sketch a few members of the vector field given by f of r equals xi. Now I'm going to think of this as xi plus 0j. I wanted that because I'm going to do this in two space, and I just want to think in terms of what's going to happen with the y component. So if I draw this thing out now in two space, what this is saying is that if I pick a point, let's say 1, 1, this has coordinates 1, 1, comma, 1. Now, what this is saying is that from this tail, I'm going to start and I'm going to create this vector. This vector, the x component is equal to whatever the x value is, and the y component is 0. That means if this is 1, out here somewhere is 2, my vector is going to go a length of 1. So it's going to stop just like that. Now, if I'm really close to the y-axis, say I'm up here at x equals 0.001 and y equals 3 or something, if I'm really close, then the length of x, this component, is going to be very, very small. As I get farther away, come over here to, like, say, x equals 5. Doesn't matter what my y component is. If I'm right there, my x component is going to be 5. So this vector is going to have a length clear out here to 10. So in general, what I can see happening is these vectors are getting huge as I get farther and farther away from the x-axis. So in general, my vector field is going to look something like this. Now, in the opposite direction, when I'm at -1, I'm going to get just exactly the opposite. If I'm at -1, 1, actually it doesn't really matter what the y value is. If the x value is -1, I'm going to have a length of -1. Likewise, if I'm very close to the y-axis, these vectors are going to be very short. The closer I am to the y-axis, that means the smaller the value of x, that means the smaller these vectors are. As I get farther and farther away, they're going to get bigger and bigger and bigger. So in general, that's a quick rough sketch of what this particular vector field would actually look like.